And welcome to a brand new week. A new series, maybe? Well, not quite, but yes. A new series in Amberskies, research and development. Obviously I have a job to do, so I better get on with it. Let's get this microphone in the right place. Yes, that's better. Yeah, my name's Blades, and today's going to be a bit more of a setup day, and I'll throw in what I've been up to over the weekend, which is learning a bit about Vulkan and its ridiculous complexity, according to people. Yeah, as if. Okay. Vulkan has ridiculous complexity. Let's just say that might not be true. It doesn't know. Okay, let's get ourselves a console. Pop it here. And we'll pop it down here, because I'm going to need one. Down a bit more, down a bit more. Oh, we've done it. We've got a console. I can't really see the reading of the writing on there, so... Here we go. Is that any better? Bit more? Bit more? Might be too much. Okay, let's just reel that back a bit, otherwise I'm not going to be able to fit anything on the screen, am I? Ah, bless. So, how do I do my job as a research and developer? Well, I have a server, and let's see what it can do. Let's try that for a server. Yeah, that looks okay. 30 packages can be updated. Yeah, that's alright then. Okay, CD. Public repos, and it'll be Twitch, won't it? Yeah, looks good. Yeah, it's got everything on it. Need a public repo. Let's have... Oh, I didn't want to do that. That was a bad idea. Okay. Git init bear, isn't it? And we'll have research. I'll just put it as research. Yeah, okay. Initialize done, okay. And that's going to be an exit. That's all I need, isn't it? That's all I need. CD Twitch. Make sure that's the same place. Yes, it is. Okay. Yeah, we'll just use a git clone, can't we? Git clone SSH :/forward, and it's going to be Fraser at 192.168.100, home of Fraser, and that's going to be public repos. And we've decided on research, haven't we? Yeah. Oh, no, Twitch, is it? Do I need to put Twitch in? Yeah, Twitch. And research. Good. That's exactly what I wanted, so just exit out of here, can't I? So I've got a blank repository called research. Alrighty. Let's grab a bit of Qt Creator. I like Qt. Qt's nice to me. Oops, a bit over one-sided that. Let's get that squared up. Alrighty, not big enough, you say, not big enough. There it is. This is Qt Creator. If you don't know what Qt Creator is, where have you been? Ah, dear. Oh, gosh, good grief. Where's my coffee? Good morning, coffee. Good afternoon, coffee, should I say. As you can see, I've been messing around with the Vulkan sandbox in Qt Creator. Well, that's not going to help us, so... recent projects can clear that menu. Twitch, I want. Open session Twitch. Default last session. Okay. Current session Twitch, yeah, that's it. Right. So we want a new project. I'm just wondering how to do this because normally I'd just go for Qt widgets. Yeah, let's do that then. Just use the first one, or do you want console? No, I'll have Qt widgets, stuff it. This is going to be interesting. And this is going to be called Vulkan. And it's not going to go to the workspace, so browse. It's going to go into Twitch and research. Okay, use this as my default location. Yeah. I like that. It's going to be desktop. Oh, details. No. I don't like these. This is where this one doesn't get it right. This is the Linux version, isn't it? The Windows version doesn't do it badly. This one does. You see, that's what it should say, but then there's this warning comes up which we just completely ignore because we like that. So to comply with Windows, that's what Windows would give. Yeah, I'll do it the same with the profile as well. So there we go. We match Windows now. So Vulkan, debug release profile. Okay, next. Main window, Q main window, blah de blah de blah. Yeah, that's fine. Next. Configure for Git. Thank you. You've already done it. So you're brilliant. Thank you very much. And don't tell me I've crashed it already. No, I haven't. Oh, wow. General messages. Always check general messages. First thing you do with this system is make sure you don't get anything stupid coming up in here, because if you do, you got to redo. Make sure everything's okay. Right. So Build. Make sure it builds. Please say it builds. I haven't done anything. Oh dear. Alright, it builds. Run it. There we go. That's what we've got. Alright. Nothing fantastic here going on whatsoever. Righty. Now, if memory serves me, yeah, we do have a form, I know, but let's just see what it is. Views, nope. Containers, no. No. Nothing in here is going to be interesting. We do have OpenGL. Right, so we don't have Vulkan. Okay. So we are going to need something like this OpenGL widget. That's going to be interesting. Alright, so what we're going to do is ignore this for a minute or two. The main UI, and we're just going to get on with it. I think that's going to be the easiest way of doing it. What have we got here now? Main, here we are. We've got a main. Queue application. What do I want a queue application for? What have we got in here? Core and GUI. Oh, that's all we need. All this deprecated stuff doesn't mean anything. Yeah, that's fine. Don't need to change anything there. Okay, let's play around in main then. Let's see what we can do. Queue application. I want a GUI. Let's have a GUI application. Let's do that for starters. And let's call it something normal like application, shall we? I'll come back to this main window business later on, because at the moment I just want to do something with Vulkan. Not honestly too bothered about that bit there. Okay, so I'll just switch that off for now. Yeah, that's easy enough done. Okay. Alright, as you can see, Qt's nice. It's got a nice editor. It has nice colours, which everybody can see, including me. And the writing is, by the way, I can do this with the writing, can't I? Yeah, 160% zoom. That'll do, 160. There we go. So everybody can see it. Nice large writing for people like me. Right, Vulkan. From what I know so far, don't really need that include at the moment, do I? I'll keep it. I don't care. We'll leave that. Hash include. Let's see if we've got any Q Vulkan stuff in here. Q Vulkan. Oh, we do. Oh, that's nice. Because Vulkan needs an instance. So we'll have one of them. Hash include. And let's have a look at this then. Q Vulkan. No. I don't think we're going to need anything more than else than an instance, really, are we? We've got any logging? We've got logging category. I think that might cover it. We'll see. We'll see. Okay. First things first. What have we got? Oh God. Why is that doing it badly? Why is it putting it up there? It shouldn't be doing. Tools. Options. Text editor behavior. 4 with spaces. Follows it's right, okay. Yeah, okay. Whatever. You should follow those now, I hope. So what do we have here? Q GUI application. First of all, what is that? That's the first thing we've got to know. So I've already set this up. I was hoping I'd set this up a bit better than that. Class manages QGIT, yeah, control flow. Now there is something different about this one, is there? Yeah, here we go. Main event loop. So this will do our main event loop, basically the main application loop, or game loop, or whatever you want to call it. System-wide and application-wide settings, okay. Can only be a 1. Oh right, for Q widgets we do need Q application. Oh, okay then. So that's why it was fine. There you go. Sorted. As it provides some functionality needed for creating widgets. So, this really, how far across do I need to go? About this far, I think. So, Q application gives main loop plus widgets. Okay, that's what that gives. argc is, if somebody doesn't actually know what argc stands for, let's put it in, number, so that is number of command line arguments, and argv is the value of the arguments passed in. They are passed in to the program in case you want to. So that's okay. So that's what that is. We can get rid of that for now. There we go. So that's what we've got so far, and all that does is runs the main loop. Main loop and event system. There we go. That's all it does. So, on our way to Vulkan now. What shall we have? What shall we have? Coffee's always good. We should say welcome to chat. Welcome. All. There we go. That's chat. Just to show that I can actually see it for once. It might be on a different screen, but it's there. I can see it. It's big enough screen. Right. So Vulkan comes with a validation layers, and what I want to do then is make sure that we've got them. Logging category, please. And that will be set set filter rules. Q string. So we are going to need to use. Oh, it hasn't done. It's supposed to follow. Oh well, never mind. Q string literal. And that'll be an open bracket. Thank you for that. Q string literal. It's an interesting idea, Q string literal. We'll have a look at that in a minute. We'll need it as a string, obviously, and that will just be Qt. And we'll have Vulkan. And we better turn it on. It's a switch, so we'll make it true. That's fine. Okay. So that's what we're giving ourselves. Q logging category. First of all, let's have a look at this and find out exactly what it is. Class represents a category or area in the logging infrastructure. So this is the logging infrastructure. It's identified by a string, yeah. You can enable or disable logging of messages per message type. So, is debug enabled, is info enabled, is warning, blah de blah de blah. Configuration categories, yeah, okay. Convenient declares and creates objects. So we could actually declare it as an object. Okay. So is there anything I can add to Q logging category set filter rules? Oh god, this has got a full thingy, hasn't it? Configures categories for logging. Okay. So space con figures Oh, what a horrible word. Categories for logging. This is the interesting one, the one that I wanted to look at, because let's see how they describe it. Because I know it's yeah, it comes with you, yeah. QString class, QLiteral. See if it'll actually. It's QString literal. It's a multi-purpose type thing. Because as you can see, you can have Latin strings, different things you can have. So you can, what a QString literal means, it is literally a string. It's a special kind. It's a macro, yeah. Generates data for QString out of the string str at compile time. Creating a QString from it is free in this case, and the generated string data is stored in a read-only segment of the compiled objects file. So it's pre-compiled. It's like it creates a pre-compiled type thing. So creates a string and stores it in read-only. Yeah. So creates a string stored as read-only for compiler. It's a way of, how can you put it, getting a compiler to set up a memory location free of charge. Really, because it's read-only memory. This is just instruction. So this just activates Qt Vulkan logging. Yeah. Well, the logging system. Validation. Does this actually activate validation or not? No. It doesn't. It just activates the logging system. That's all at this stage. Alrighty. As long as I don't get mixed up with that one. Validation layer, you can switch on and switch off separately, I guess. But if Vulkan throws an error, a wobbler. There we go. Hash define QString literal string. Blah de blah de blah. No accept. Oh, it gives you a QDecl and no accept on it as well. Nice. Goes into header initialization. Yeah, okay. Radio. It does quite a few things, put it that way. So, we're going to need an instance. I think that's going to be quite easy to do, really. Probably just something like Q Vulkan instance. We'll just have inst. There you go. That was easy enough. How about that? Yeah? So, inst dot set. This is where we're going to start setting layers, I think. This is where the fun starts. And it's going to be a qbyte array list. Yeah, okay. Have we got one of those? Oh, it'll be the within the instance header. So yeah, we have qbyte array list. Yeah, that'll do. And we'll just put you in here. So we're going to have Vulkan starts with a VK. It's a layer. What else do we need? And this is where it gets a bit weird. Don't ask why, but we're going to use Google threading. I've got a horrible feeling that Vulkan was designed by Google, maybe. Or they own it. And it's not going to be threading like that, is it? That's not a macro. Right, VK layer Google is the macro, and threading is a part we want of it. Okay. What else can we have? VK layer. Alright, let's have some normal layers now. If you checked out Vulkan, if you're on Windows, you will now go check Vulkan Lunarg and download that. That's what you're going to be needing. This being Linux, well, you just add it with your manager thingy. Yeah, you know what you mean. You know what I mean. Your manager thingy. Yeah, your manager thing is good. Let's have a look. Parameter validation layer we'll need. Yeah, so that's parameter validation. Does that look right? Yeah. Okay, we'll put that there to stop you from whinging. I'm still going to keep adding to it. VK layer. I'll stick with Lunarg now. I think until probably the last argument. Object tracker we'll have. What else can we have? I wonder why they call it Lunarg. Lunar argument? God knows. Yeah, well. Core validation. We've got object. Yeah. I'm just running down all the stuff got. Of these. Layer. Yes, I did quite a bit of work this weekend. I'm a workaholic, basically. When do I get time to play games? Yes, indeedy. During the daytime, when I'm not working. Usually. I do most of my work at night. Images. We'll need images. So we'll have that. Nice easy one. We are coming to the longer end of these, aren't we? I hope. What have we got here now? Image. Oh yes. Oh yes. Swap chains. Definitely. Swap chains are back buffer to front buffer swapping thingies. And there is like a pipeline chain that you have to define. And you can have many swap chains. So you can have many like pipelines all defined. And you can run them all in parallel. Isn't that lovely? Doesn't that really make you happy? I mean, it's an interesting. I think I've run out of things to do with Lunarg now. It's definitely an interesting idea because it makes graphics programming wonderfully easy, to be honest with you. I'll go back to Google for this one. What do we go for? Unique objects. Obviously, Google has some unique objects it wants to play with. And I'm done. There we go. What can we say about this then? This is the instance within which Vulkan operates. List of layers for validation. Oh no, that's only one of them, isn't it? List of layers for Vulkan. List of layers which Vulkan can use. That's a better way of looking at it. A layer is just like a block. I don't like the word layer because it sounds as though you're layering things on top of each other. Well, you are. What that means, if an event goes through, it will go through the layers, or up from the bottom, or down from the top through the layers, depending on which way round it's decided to go. And once a layer can either catch it and operate it, use the event, or it can catch it, operate on it, and pass it on through the layers. It's a way of catching events, and it makes it easy, because what you've got then is blocks of code which have events being passed to them, and the block of code can then decide whether it wants to use it or not, whether it wants to consume it, or whether it wants to then pass it on. So it can either receive an event and consume it, or receive an event and pass it on and take no operation, or take an operation. It depends. But it means that events become more predictable. So you can set an event to happen, but only on one layer, and that layer then consumes that event and doesn't interfere with any other layer and the operation of any other layer. I think that's possibly a better way of putting it. Yeah, it's a difficult one, but it's a nice concept, but one that's badly explained by using layers. Because a layer to me is like this bar, a lot of these bars, or a lot of lines, and a layer is a line to me, whereas in actual fact it means a block of code, or a program even. So yeah. Have I got? No, I'm not going to go further into that. I was going to go further into it. Right. So now we've got all the information, as is true, and this is how Vulkan works. You create the object, you then set up the values for the object. Alright? Well, no, so you don't create it. You reserve the memory. That's better. This reserves the memory. Then you set up all of the switches or whatever for that memory block, and then you create it. Yeah. So now we need to create it, but we'll have an if statement for that, because it does need error checking on this, unfortunately. If, and it's a not, inst. I don't like doing it this way, but hey ho, create. There we go. So if it doesn't create, we're going to use something called QFatal, because it's gone wrong, and that means it'll pass out of the program cleanly and stop the program instead of just using quit. So failed. To create the Vulkan instance. And we can pass an argument to it, I suppose. Comma. Inst. Dot. Can we have an error code? Yeah, we can. Good. Thank God for that. So, actually, no. I'll do this properly. Just one sec. Alright, so I've actually done that. That's correct. That's correct. That's now correct. That should catch the if statement, really. I don't like doing if statements like this. I know you can. But I prefer that. Because then I can see the scope. So, QFatal. Oh. Animation framework, forget it. I'll just note that as exits program with message. There we go. And gives current error code. Okay. Okay, that's all right. Looking okay. Right, so that's your instance created. Is there much more to do? Not really, I don't think. No. Open documents, bookmarks. Oh, file system. Right, okay. New, add new, no. New folder, there we go. Let's have a new folder. Let's call it display. Let's not deviate from the way I do things. Okay. And now, does that mean I can create something? Yes, it does. I can create... I'm going to have a different file for the window. Now, I know I've already got this main window going on, but I want a Vulkan window. Okay. We'll pop that in display to keep it separate from everything. Add new. It'll be a C++ class. And we'll call it Vulkan window. And this is going to hold everything else, I think, really. Don't know if I want to put anything in it. Path to display, correct. Next. Git finish. This file is not part of any project. Yes, it is. Get away. I can prove that because I can now do that. You see? Puts it in for me. And yeah, it's gone to lowercase. Fair enough. Don't care. Yeah, I think we can fill this in. Let's make a Vulkan window, but first of all, I'll just make the thingy here. So hash include, and it's going to be display Vulkan window.h. Lovely. So I won't forget. We'll come back to you in a minute. Right, so the header file for this is pretty simple. Oh my god, if and deafens. Oh god. Well, there you go. What do we have for a Vulkan window? It's a class. Alright. I disagree with what I've just done actually now. Nah, stuff it, I don't care. Because this is just research, so that's fine. It's just that I haven't done my normal setup here. But anyway, hash include. Let's include something. So I'll have Q. Vulkan. Now Vulkan needs devices. So I'll have those. Include. Yeah. It's going to be one of those days. Q. Vulkan. And what else do we need? Window, maybe? Yeah, we do have one. Good. Right, thank you. That'll do me then. So class, Vulkan window, and public. And we'll have QVulkan window, please. Bit like that. Yeah, that'll do. I should namespace it really. And it's going to be research, I guess, and you've done this horrible thing which I don't like. Thank you for that. That was very kind of you. Does this have an automatic reformatter? I don't know. Advanced. Auto. Okay. Weird. Alright, I'll do it myself. Class. Alright, you should be tab 1. Tab 1. Tab 1. Tab. Effectively 1, 2. No, I'll be 2. 1, 2. Yeah, right, I'll have it like that. That looks nicer. Yeah. Let's have it like that then. Public. Don't really want that. That's pointless. Vulkan doesn't work that way. Right, that will create a window. So what we want is the renderer for the window. Yeah, Q Vulkan window renderer, create renderer, override. Okay, we'll take you. Don't want to put anything in there, so we'll just take you. Alrighty. That's it. Okay. So I might as well put that in here as well. Class. Vulkan renderer. Vulkan renderer. And that's going to have a Q Vulkan window renderer, is it? Yeah. That can have one of them. Yeah, because we need to use it here. Yeah, okay. So that's a new class. And we're going to need the window. So that's Q Vulkan window. I'll have one of those. Start underscore window. Normal kind of thing. Device functions we'll need. And that's going to be start underscore device funcs. Okay. It's just telling me that they're not used. Okay, that's fine. And to test, we'll need a test. So I'll have a float tester. Yeah, okay. Float tester. That'll do. I'll probably use that as something. Public. And of course it's come down too far because I didn't set these up far enough. What do we want on public? We want the renderer. Yeah, Vulkan renderer. That will take in the window. Yeah. Yeah, I think that's about fair. Right, we only need a couple of things here, really. Okay. What are we going to need? Right, I'm going to make some very, very bad things here. So init resources override. Yeah, we'll do that. And we better init swap chain resources as well. Because it's going to need both of those. Void release. So release resources first. And this is just habit doing it backwards, isn't it? Well, no, just do the same way around. Release swap chains. What else we got there? Logic device lost. Oh, right, yeah. Yeah, we can do those as overrides. So that's me chains. We'll need one more, won't we? Yeah, we'll have that one. Think that'll do for the basics. Okie dokies. So, have I got an auto refactor? Think I do. He doesn't seem to be coming up. Switch follow, blah blah blah. Find reference open. Refactor, here we go. Add definition. There we go. No, we haven't used you, sorry. Sorry, mate, but you're just not going to get used. We are going to need a namespace. Research. Stop doing that. There we go. I'm sure I've missed something here. I'm not used to things going this smoothly. Oh, it's because it's doing it for me. Oh my god, I had to become a very good programmer all of a sudden. Yeah, right. Okay, we can refactor you, can't we? Yeah, that seems to work alright. I'm happy with that. Just refactor them all. So that's init resources. Doobry doobries. Does it not come up these days? Oh, it probably does, but I've missed it. Let's put these all up. How lazy can you get? I mean, that is ridiculously funny. And refactor you as well. There we go. So, that's done it all for us. Magic. Okay, let's start here then. I suppose... What can I do for this one? So this is Vulkan window. This isn't going to be much in here, is it? Create renderer. Alright then. Return a new Vulkan renderer. And that will be this. Right, it doesn't like new. Cannot cast research Vulkan renderer to its private base, Q Vulkan. You sure? Bet I can. What happens if I... This is a Vulkan window, isn't it? To base class Q Vulkan window renderer. Alright, I'll come back to you. Ah, well. What's this next one? Vulkan renderer with a window. Okay. So your end. We'll put a colon on you. M window. Comes from the window. M underscore devfuncs. That's going to come from a null pointer, because I've got one yet. And M underscore tester. I'll start as 0.0f. It's a float, isn't it? Yeah, 0.0f. There we go. That's that easily done. Header file. Oh, it's going to do that sort of thing, is it? Okay. Let's get ourselves an IO stream. Null pointer 0 as STD. Yep, that's better. What we're going to tell ourselves. Vulkan renderer constructed. That gets constructed here. So that's okay. And that's an STD end line. Okay. Now, we get to all of these overrides, don't we? Let's do some overriding. What do we got? I'm going to use QDebug for this. It's an easier way of doing things. It also writes out to the debug console, which is sometimes useful. Let's debug something, and what we're going to put in here is init resources. SOURCS resources. Yeah, that'll do. Okay, that's that one done. These are difficult, aren't they? Q debug. Yes, this is Vulkan, folks. Can you see I'm not actually programming it? Instead, I'm just telling myself about it. So this is swappy chainy thingy. Actually, I better do something in here. We better set it up. M underscore dev funcs equals something or other. It'll equal your window, which is a pointer. And it'll be the Vulkan instance, if we have one available. Okay, V. I've got surface and instance. Yeah, we'll have an instance. So, Vulkan instance, yeah. Device functions. So, device functions, there you go. And that will be for whatever window device we're using. So I don't know what it's going to be. Probably the TV screen, something like that. There we go. Do I really need something on here? Dev funcs. Okay, I'll put it on this one. Basically, that's what it does. Like the TV screen, mostly. Or in this case, it isn't. It's the graphics card. It's your graphics card output, which comes to the TV screen. So it's your graphics card, really. Init swap chain resources. Okay, init swap chain resources. Alrighty. I'll qdebug that just in case we need to put anything in here, which we probably don't need anything else. I think we only need the functionality at this point in time. Right, okay. I'm just going to, yeah, I'll just qdebug them in case it needs anything. If it does need something, then it'll tell us in debug that we need it. If it accesses any of these. So this is they should come up these actually anyway. Release. Swap chain. No, that's not swap chain. Release resources. Duh. Yeah, okay. And qdebug. And this is release. Swap chain. Resources. Excellent. We're getting we're nearly done now. Really? I think we're virtually coming towards the end of this little experiment. Let's do something with the screen. So mtester. Let's test the screen out. What we're going to use the tester for? Just a colour, any colour. Plus equals 0.05 or something, I don't know. That'll do. Yep, okay. If mtester goes above 1, we need to just reset it back to 0, I think. If we're doing colours, equals 0.0f. There we go. There we go. That's what we use it for. So, Vulkan starts with VK, doesn't it? VK. Clear. Gosh, that brings up a nice lot of thingies. Clear colour value. Okay. So, clear colour, or our clear colour, we're going to name it something. This is exactly the same as you do with OpenGL. Just in a different format, that's all. I want this as a single block. I'll scope it one more. 0.0f. That's red. G. I'll use blue for mtester. Why not? And alpha. Alrighty, that'll do. Yeah, there's that to go there. Unused variable. Funny. Okay. Right, so we've got a clear colour. Now we want the depth buffer, don't we? Or depth. Well, it calls it a depth stencil. So it's a VK, just because it calls it something different. Doesn't really matter, does it? Clear. Have we got anything to do with depth here? Yeah, there we go. That'll do. A depth stencil. Okay. Just have 1.0f. The reason I've had to use a second thingy there is because all of these make one colour, whereas a clear depth stencil is slightly different. We are going to clear it between the values of 1 and a separate value of 0. No, it's 0. It's not 0.0f. Because, don't know if I can get this up on screen. Does it tell us what it is? No, it doesn't. But it is a 0, it's an int. So it's a float and an int. It uses structs type ideas in the background. So what you are actually filling in is structures of data, which is why there's all these little semicolons to do as well. Will we need anything else? Clear values. I think this goes together with this. I'll soon tell you. VK. Clear. Yeah, value it does, yeah. We'll have to have 2, won't we? Yeah. No, I'm not doing it that way. Okay, I'm going to use memset instead. So, clear values. Okay, thank you for that. Clear values. With 0. And we're going to just need the size of, and its clear values. possibly... What? Expected semicolon after expression. Oh yeah, it's here. Huh? You can't accept that format of memset. You're acting a bit weird. Okay. I've got a semicolon missing somewhere. I'm sure I'm allowed to use it this way. Okay, I'll ignore whatever it's saying. Oh. It's me being an idiot, isn't it? That's memset's a function. There we go. Sorry. I'm just thinking in the wrong alignment there on my head. So clear values. We're going to have 1 or 0. And that now needs dot color equals clear color. Okay, and clear values 1 dot depth stencil equals clear DS. So that's assigned those two. So that assigns all our clearance values. So we create our clearance values here and here. We then assign them into the clear values, well, 2 buffers. That's one buffer and that's a different buffer. One uses the clear color and one uses the clear depth stencil. So hopefully that isn't too complicated. And that means we can now begin the pass. So VK. Again, you set everything up and then you do it. So VK render. I want to begin. And this will only be the information. Is that correct? Yeah. And we'll call this a render pass begin info. Okay, that'll do. Now, we're going to do this memset thing again. Yeah. Yeah, we'll do that. So, memset. Alright, I need an and percent sign. And it's going to be RP begin info 0. And then again size off. There we go. Lovely. Now we're going to come to the interesting bit. we're going to have to set it up, this beginning. So what we need to do is now give our graphics card all of the information that it needs to be able to begin the render pass. So we have complete control over our graphics card right now. Yeah. Don't you like that idea? You're getting absolute complete control. And this is how you begin the renderer. So we're going to have an RP begin. Render info. Dot I want to type. I'll take U as a type, an S type, equals the first one, which is VK underscore structure type render pass begin or something. There's a few of these, isn't there? Wow. That one. These are all the different structures you can have, by the way. Right, do I want KHR or just info? I'll take info. That'll do. That is 43. There you go. So the type is 43. There you go. Wow. That's what it means. RP begin. What we're going to have now, render pass. Oh no, not render area. Render pass equals, and this is where we need our window. And this could, we're just going to use the default. Easy as. Nothing special going on here. Then we can do an RP begin. Well, we haven't set up anything else, so I think default's probably the best one to use. Info, and now we'll just need a frame buffer, won't we? And that's going to be on our window again. We want the Windows frame buffer. So that's going to be current. Current frame buffer. Yeah, that'll do. We need a size. We need to know the size of the window. And of course that's changeable. So I'm going to put a const Q size in here. And we're just going to call it size SZ. It's immaterial, it's not going to live very long. Underscore window. And this is just going to be your swap chain. Image size, yeah, that one there please, thank you. So that just gives us the size of the window. There we go. So we know what's going on. Let's carry on. RP begin. What else do we need? Render area, that's what we're getting to now, isn't it? Yeah, render area, and we're going to need dot extent width equals a static cast to an unsigned int of sz dot width. That'll do it. Semicolon. And repeat. Dot render area. Extent. It virtually guides you through it. Static cast to an unsigned int. And it's sz dot height. Done it again. Get that bit of spacing, I think. There we go. So that's those two done. So we now know what the render area is. Need a count on clearances, don't we? How many clear values have we got? Got to tell it. RP begin. And this is going to be clear value count. That's just going to be equal to 2. I've only got 2 of them, haven't we? Got 0 and 1, so 2. That'll do. And I think finally, what do we need? The clear values. The pointer to the clear values themselves, which will equal the clear values. There we go. That's that. Which we've set here. So clear colour and clear DS. 2 of them. So that's all set up. So there's not really much in there that you wouldn't expect. The only thing that's different is we've got this VK structure type render pass begin info, which is Vulkan's way of giving an instruction to your graphics card saying, right, we're setting up the render pass. And then it will set up, and it will give, at this point, the structure. So this sets, all this is doing here is setting up a structure and feeding it into this line here. And when this line gets activated, all of this lot will go with it to the render card, to the graphics card, sorry. And they're all pretty self-evident what they're doing. So we're asking, see, we can't clear the screen unless we tell it how to. Exactly. I mean, it's not going to guess, is it? You're going to have to tell it how to do it. You're doing OpenGL, so you're doing Vulkan. It's just the same thing. Okay. So let's set up ourselves a command buffer. We can have a command pool. Ooh. Ooh. I just want a command buffer though, don't I? Just a normal one will do. Buffer. Yeah, that'll do. I don't want anything fancy, not this time round. So our command buffer is equal to m_window. Everything has to do with the window. So everything is inside our window, m_window. So we want the current one. So current, and it's going to be command buffer. So there's nothing silly going on there. And all we're going to then use is our device functions to make this happen, as it were. So this is now going to set off our render pass. So all we've done now, so far, is we have set up the clear screen and the clear depth buffers, as you would do in OpenGL. We've cleared them, and we have set up the area and also the clear values here in one big thing. You have to redo this every time. You could do this just once as a function and then just keep passing in and out of it, but that's not usually a good idea. I might go with that far later on. Not sure what I'm going to do with this, but we have to be careful, because if the window changes, we have to change everything because our swap chain image size changes. So our whole swap chain changes. And we're going to have a pool of these. Yeah, a pool of them. As you can see, there was like a command buffer pool. Yeah. It's threaded. So it all lends itself to threading. Safe threading at that. So at the moment, we're just using one thread. So you can't tell it's happening. So we'll get our device functions, and we're going to actually now call the command, which is vk. This is quite funny. Command. We're not going to draw yet. No. CMD begin render pass. That's the one I want. Right. Now what do we need for this? Whoops. We need the command buffer. So that's CMD buff. We need, what's next? The begin info. So that's RP begin info. Wants a star, does it? Yeah, okay. And RP begin info. Right, we'll just tell it, just do everything else in line. VK, so it's subpass contents, we'll just use inline. Yeah, that'll do. For now. Until I learn more about the subpasses, we'll just do that. Yeah. Right, there you go, rendered. So it's not complicated at all. So the actual base renderer for Vulkan is that simple. There we go. Well, the rest of this is now we're on cleanup. Yeah. So we are going to do an mdevs function, and it's just going to be vk command end render pass, and that's it, really. We've got to use, of course, our command buffer for that. That's that done. Anything else we need? Yeah. Window. We want frame ready. Don't need anything else there. Underscore window. In other words, we completed our render pass, so we're now frame ready. In other words, we're now ready for the next frame or whatever. Window. Sorry, we're not. That's a bad way of putting it. I'll try and explain that in a second. Request. Update. In other words, let's update the window. Not really much to do. So this just says render continuously. We can throttle that by presentation rate. It's called presenting. So all we're asking it to do is render continuously. Use a full stop, and that's a capital T. But we can throttle it by presentation rate. we can control our presentation rate, how many times per second we present to the screen. So that's that done. Yeah. What's hard about Vulkan? Not much here. There's not really much to it. That's actually a bit quicker. I don't see what the problem is here, but I do understand that it's got a complaint to make with me, which is fine. I'll sort that complaint. No, implicitly declared private here. Wait a minute. I've implicitly declared it private. Have I? Sorry. Yeah. You were quite right. Thank you, Qt. You see? Qt actually helps. So there you go. That's what you need. You set up a renderer, and you then write your renderer. Not bad, huh? We're ignoring you. So let's go back to main and finish off, shall we? So we've got our Vulkan window now. We've checked on all of this lot. So we've set our rules, we've got our filters going, we've got our instance. Let's just use it. So how do we use it? So I've just checked our instance, haven't we? So what we're going to do is research Vulkan window. Oops. Vulkan window, and we'll just call it window. So we've just done that. We can now do window dot set Vulkan instance. There we go. And inst. So we can set up our Vulkan instance. There we go. There it is. Window resize. You've actually got to resize your windows now. You've got to do it properly. 900 by, I don't care. I don't think this is one that it will like. Probably not. 500 I'll have. Actually, I will do this properly. Considering I've done everything else properly, may as well do these properly as well. As they are instructions. Once we've got to this stage, it's just window show, really. That's all there is left to it, which is a standard way of saying, hey, yeah, take over. So the application now will execute that. So what it will do is it will execute on and keep executing because of that last line that we put on here. Because we, at the end of this, because it's going to run it, it has to when it creates everything, it will keep requesting updates. So it just keep updating itself. I have no idea what the presentation rate is at the moment, but hey ho. And what we get is something like, I'll have compile output. Let's just try compile output first. Oh, compiled. Okay. Yeah, that's working. Yeah, Vulkan's difficult. No, it's not. It's just that you have to take control. If you're going to use Vulkan, you've got to be willing, and you have to have the mental frame of mind of taking control of your graphics card by the scruff of the neck. What's all this lot down here, you may ask? Well, this is what we asked for. So init supported Vulkan instance layers, and then it gives all your instance layers. So we've got Mesa overlay layer, which is what it's chosen for me because I don't have a graphics driver installed. So it's using the Mesa overlay, which is an interpreter. So it's telling me what I'm using, which is brilliant. Gives you all the information. Qt Vulkan supported Vulkan instanced extensions. So it now tells us all of the extensions I can use from VKKHR. So surface capabilities. Semaphore. So semaphore, by the way, if people don't know, is to do with threading. So we've got semaphore in there for the threading. It tells us that we've got all of this stuff, and you should really read through what you've just done before continuing. Alright, so extension NVGLX missing on display 0. So there you go. I can't have NVGLX. I believe that's NVIDIA's GL extension. So I can't run NVIDIA because I haven't got it. It's an NVIDIA graphics card, but I don't care. I don't use it. Well, I test on it, but I don't use it on here. I just use it for testing. So mode display, yeah. Surface counters, 1. Yeah, that's what we've got running. Protected capabilities, 1. Wayland surface, yeah, we've got one of those. We've got 6 of them. There you go. You know, it's... So I've replaced the whole of my... What this is trying to tell me here is all of this has now replaced my NVIDIA graphics library extension. Because it's missing on the display. I don't have it. So we Vulkan renderer constructed. And the renderer has all of this in use. And this is what device extensions we support again on our renderer. The flags, the picked flags, or the mem types we've picked. You can look these up, by the way. Mem type 3 for host visibility, visible memory. 0 for device local memory. So that's okay. 50 depths, and yeah, 130 init resources. This is rather good. And swap chain resources. Fantastic. So when we exit, what happens? There we go. So on exit, it releases a swap chain, releases swap chain resources, releases the reset, so it releases the resources because we put those in there. Those are those overrides. We haven't got any extra chains or resources to release, so we didn't do any. So once you start rendering something on that screen, instead of just changing the background colour, you would start asking for resources. So when it comes to ending your program, you would have to release those resources. And I've obviously put that in here. So here you would initialize any resources that you want, and here you would release any resources you want. So you've got your initialization and releases already set up for you. And that is your basic structure of Vulkan for a window. Isn't that good? Wonder if it can use SFML. Wonder if I can use SFML. I'll leave that till tomorrow. How long did that take? 1 hour 46 minutes, and you have a Vulkan window. And I'm slow. Come on everybody, I'm slow. There's your debug, by the way. That's what it puts together for you. And all it is a main, 2 files for your window and renderer. Well, one file for your window and renderer. I should call it window and renderer, really. Or base renderer. I mean, is that ever going to change? Yeah, I mean, you're going to probably put all the header files in. What you would do is you have a lot more in here, I think. But we'll see if I do any more. If you want more, and you're on YouTube, it's down below. This is going up on YouTube straight after this session. Go down below and add, please add to the comments that you want to see more. Maybe you want to see a triangle put on the screen. Woohoo! I'll do it for you. I'll put something on screen for you if you want. But that's your base. It's just the same as OpenGL, as far as I'm concerned. That I can't see any difference there in time to actually do it, and time to set up the window and time to do it. I mean, if I was to set up OpenGL, yeah, right, in the same way, it would take the same amount of time. So there we go. Take care, keep exploring, keep researching, keep rendering, and have fun.